So, like I said before, if we have x to some power, if it's 2 to something, you do it twice that. But if it's x to a power polynomial function with a trig function attached, you want to spin the polynomial down to 0, right? So that it disappears and you just have a trig derivative. In this case, we would have to do it 4 times, so that's what the power is. But there is a quick little method here called the tabular method that we can use. So u is obviously going to be x squared because we want to get rid of that. So dv is going to be x to the 4, sorry. I don't know where I got x squared from. So it's just floating around in my head. And dv is the sine 4x dx. Okay, so you can make a little chart here. Because it's got tab. Did I say x? Oh, you know why I said x squared? Because in my notes it's x squared. So let's make it x squared. You just have to erase the 4 and make it a 2.
What if it was a pen?
What?
What if it was a pen? Some people, and they're crazy.
All right. So u and dv are in this column, and then u and du. Why my pen's not working?
Your pen not work like every single.
I know. I need a new pen. dv and v, u and du, and the signs. Okay. Sorry.
We just made this notation for no reason.
There's a reason. All right. So the sign is always starting with a positive, and then it alternates every time you go down. So it's going to be positive, negative, positive, and then I can't even alternate. Negative. All right. So we start with what u is. U is x squared. Boom. What's the derivative of x squared? What's the derivative of 2x? What's the derivative of 2? 0. Boom. You stop when you get to 0. Okay. dv, or v primed, whatever you want to call it, is sine of 4x. What's the antiderivative of sine 4x? Okay. Then you do the antiderivative of that. What's the forget about the negative quarter. What's the antiderivative of cos 4x? So it would be hmm? Yeah, I just want you to do the antiderivative of this. Okay, so then you're going to end up here. I'll do it over here. You're doing the integral of cos 4x, which is going to give you sine 4x over 4, right? So you're going to multiply that by the negative a quarter there, and you're going to get negative 1 over 16 sine 4x. And you have to do, if you want to go all the way to 0 on the u's, and so you need to line them all up. Okay, so I need one more antiderivative. Antiderivative of sine 4x, negative 1 over 4 cos 4x, which is going to be negative positive 1 over 64 cos 4x. Okay. Once you've done that, this is how you put them together. Start with the positive. Goes with the x squared, because the formula is uv, right? The v that we're talking about is that one, right? So that's u and v. So the integral becomes x squared, I guess negative 1 over 4 cos 4x. The next term, you just go down in order. Take the negative, I go across, u, and then the v of the next one is that. So those two negatives are going to be positive. So I'm going to get plus, and the 2 and the 16 I can reduce to x over 8. Are we okay with that? So I'm going to get x over 8 sine 4x. And then the next one, boom, boom. So I'm going to get plus 2 over 64, so 1 over 32 cos 4x. Throw on a plus c, and you're done. That's it. That's a lot easier, and it works well for these kinds, right? So x to the 10, you just make the table, and then you just start putting them all together. Okay? Do you want one to practice?
Sure.
One to practice, and then we'll be done with integration by parts. And apparently the class is almost going to be over. Well, it only applies in certain cases. You have to understand why. You want to do things. You're not going to use this for e to the x sine x, right? Because e to the x won't go to 0, and the trig functions just keep recycling, right? So they're good for this. No? Okay.
Is there staff meeting after school?
Not on.
Well, I was also confused
Why?
because I